Okay, welcome to FM Tuition Academy. Okay, we are continuing on electricity. Okay, so I'm going to do that question so that you can understand it. For example, the question that came was, how was the question written? It was something like this. So these are cells. Okay, these are cells, and then it came like that. Okay, this one is a variable resistor. Okay, and then it went like that. Of course, that is a variable resistor, and then it went like this, and then there's another resistor here. Okay, and then here there is symbol X. Okay, I use a different color, that is X there, and then after X, as you continue drawing it, it goes like that. The diagram goes like this, comes down, then goes like this, and then you have got Y here. I already taught you how to do this last time. Okay, what is Y? Okay, that is my Y there. Okay, so this one is called a variable resistor. Okay, that's the name. That's got an arrow cutting it like that, an arrow coming like this, cutting it. That's how you know it's called a variable resistor. It's a resistor but with an arrow. Okay, with an arrow. A resistor with an arrow cutting it like this. Okay, it's called the variable resistor. Okay, let's go to the actual questions so that I help you to understand this type of questions, because they may come in your exam. So, question A. What is question A? What is the name of the instrument X? What is the name of the instrument X? I already taught you how you know this. You remember what X is? Since it's in series connection, this X here, I told you it's a what? The ammeter, because always the ammeter is in series connection. It is always in the series connection. It's always in this connection. The ammeter is always in that connection. Anywhere here, where it lies, anywhere here, it's called the ammeter. So this one is called the ammeter, if you remember what I said. So the instrument is called ammeter, and it is used to measure current. Okay, that's the instrument. Question B. Okay, question B. What is the name of the instrument? B. I mean Y, sorry, not B. The instrument Y. What's the name of the instrument? Y. So you go back to your drawing. What is Y? Y, what's the name of the instrument Y? The name of the instrument Y, this one, Y, is across this resistor. I told you whenever it's across a resistor, it is called a voltmeter. So Y is a voltmeter because it's across the resistor. This one is across this resistor. Okay, so it's called a voltmeter. A voltmeter, I think I explained last time, it's called a voltmeter. See, so all these are marks. Okay, question C. We are going on question C. What was question C saying? Question C says, using the experiment above, the graph below was obtained. Okay, and how was the graph? It's a graph that I've already given you. Okay, so using the experiment above, the graph that was obtained is as follows. This is a graph that was obtained. Okay, so it goes like this here. Okay, the graph that was obtained, it is straight here, and then here it goes like this. Okay, that was a graph that was obtained. It goes like that, and then that is my graph that was obtained using the experiment. So there it has the following numbers. There is 1 there, 2, 3 and 4. So here it's 1, here it's 2, here it's 3, here it's 4. That's a graph that was obtained. And then here we have got yes, here I've got 1. There I've got 1, 2, 4, 6 and 8 there on top. Okay, so we've got these variations. So here it's 2. I'll put the numbers this side because of space. So here it's 2, but you put the numbers the other side. 2, 4, 6, 8. Okay, okay, like that. So that line goes, I'm not drawing that line properly. So this line goes from there up to down. So there it's 2, there is 4, 6, 8. Okay, so down there, what is there down? So you need to know the parameters that are present down and the parameters that are present on top. So down is current. So here down is current here. Here down it is current. Okay, the numbers down have got current, which is measured in ampere. Okay, ampere, P E R. Okay, close bracket. So the numbers down have current, and then the numbers this side have got voltage. This side is voltage. Okay, voltage. Okay, down is current, horizontal, vertical, this side is voltage. Okay, and then there was a line that came using the graph that came. There was a line that they had put for you. What line did they put for you? They drew for you a straight line that is coming in this manner. The line was coming from the line was straight. The line was straight. It was coming like this, straight, and then it was coming like that. Okay, that's how the line was written, this line. That's how they drew for you the graph. And then the first question they asked you from this graph was the question below. They were asking this question from the graph. These questions are coming from the graph. Okay, question 1. Question 1 says, what conclusion can be drawn from the results above? That's question 1. What conclusion can be drawn? What conclusion can be drawn? What conclusion can be drawn? What conclusion can be drawn from the results above? What conclusion can be drawn from the results above? Okay, so what these results mean is, if you look at these results, you see it's a straight line that's coming like that. when a line is coming cutting this into two, okay, like for example this part and this part, you see this part and this part, they look as if they are triangles. Have you seen? There's a triangle there, and then there's a triangle here, like a triangle this side. Have you seen? Even that side like a triangle. So it means current is changing with voltage. So current is changing, also voltage is changing, because this line is a straight line. Okay? So it means current or voltage is direct proportion to current. That's a conclusion. Whenever there is a straight line like that, meaning the conclusion is voltage is direct proportion to current. That's a conclusion. Okay. Voltage is direct proportion to current. In short, when voltage changes, current changes. Voltage is direct proportion to current, or current is direct proportion to voltage. It doesn't matter how you write it. They're just proportion to one another. They're direct proportion. They are direct proportion. Direct proportion. Direct proportion. Okay? Question B. From the graph. What is question B saying, guys? Question B says, what is the voltage when the current is 2.5 amps? Okay? What is the voltage when the current is 2.5 amps or ampere? Okay? So what is the voltage when the current is 2.5? So you go to the graph, you locate where 2.5 amps is. Where's 2.5? Where is 2.5 amps? This is 1, okay? This is 2. 2.5 is somewhere here, okay? So you are trying to find the voltage this side. So you draw a horizontal line from 2.5. Have you seen? 2 is here. This is 2. 2.5 is here. So you go 2.5, you draw a horizontal using a rule to the line above. So it comes to this line above here. So you draw a straight line like this. 2.5. Have you seen? 2.5. And then you draw a horizontal line going in this direction. Okay? You go to pick a horizontal line going like this to pick the voltage there. The answers will not be same. It will be different. I don't know what answer you are going to get there, because this diagram is not drawn to scale. So you can find this is 4. Have you seen? So this is 0, 2, okay, 4. So here it's 5. Okay? Because this is 2, meaning here it's 1, okay, meaning there it is 3. Because if here it's 2, meaning there's a 1 on the middle. If here it's 2, meaning here it's 4, meaning there's a 3 on the middle. So if here it is 4, here it is 6 on top, meaning here it must be 5. So it means from 2.5 here, I drew a straight line going in that direction. Okay? From 2.5 here, I drew a straight line going in this direction. And then I went to pick the voltage this side. And what is the voltage there at that point? It is 5. So it means my voltage is actually 5. So I just pick using the graph. So my voltage is actually 5. When you draw, it may be 3.5, it may be, I don't know. When you draw, you're going to draw your own graph. So the answer may not be 5. Okay? So the voltage is actually 5 volts. Okay? I don't know. When you draw, you may find maybe the voltage is the 4.5 or the voltage is 3.5, because this diagram I've drawn is not on the book. So when you draw yours, pick the answer that you are going to get using your own diagram. Okay? Because my diagram is not drawn to scale. I'm just teaching you how to do it. So question, that was question B. Now we go on question C. What do you do with question C, guys? Question C. Question C says, calculate the power by the resistor R1 if the current is 2.5. Calculate, actually, this one is R1, okay, resistor 1. So, the question is, calculate the power used by the resistor R1. So I already know the formula for power. Power is equal to voltage. First, the same. Calculate the calculate the power used by the resistance R1 if 2.5 amps passes through it. Okay, so you find the formula for power first. Power is equal to voltage times current. So is equal to the voltage. The current you already know is 2.5. What is the voltage? So you pick the current at 2.5. You see, at 2.5. Have you seen the current at 2.5? So the current at 2.5. So calculating the power provided the current is at 2.5. So at 2.5, what was the voltage that I obtained? Okay, at 2.5. At 2.5, the voltage I got was what? 5. Okay, at 2.5, the voltage I got was 5. So it means I have to multiply 5 times 2.5 because the voltage at 2.5 amps is 5. So I have to multiply 5 times. So the voltage is 5 times current 2.5. Okay, so what do I have? So I'm multiplying 2.5 times 5, which will give me 5 times 5 is 25. 5 carry 2. 2 times 5, it's 10 plus 2, 12. So it will be 12.5. So meaning my answer here is 12.5. Okay, my answer there is 12.5. When you multiply 5 times 2.5, it will give you 12.5 W, meaning watts, because power is measured in watts. Okay, question D. I'll put question D here. Question D, I'm going to write it. I'm going to include it there, though it was not there in the question, because I want to make you understand something. Question 5. Okay, first I'll write question D, the one that's in the question. Calculate the resistance R1. So calculate the resistance R1. So resistance is equal to voltage over current. So what is the voltage at R1? We already found the voltage. The voltage was what? 5. We already found it at R1. 5. What is the current? The current we found was what? We already found the current. The current was what? 2.5. That's the one that was passing through it. 2.5. Okay? So it is 5 divided by 2.5. So it is resistance is equal to 5 divided by 2.5. And we said whenever there's a decimal point there which has one placeholder, you multiply 10 on top and 10 down. The decimal point disappears. So 5 times 10, okay, over 2.5 times 10. So 5 times 10 is 50 divided by that decimal point will disappear. Only 25 will remain. So it is 5 divided by 25. So resistance is equal to 50 divided by 25, I mean. So 25 into 25 is 1. 25 into 50 is 2. So it will be 2 ohms. Okay? That's how you do it. That's how you do it. I'll make a new question for you. I'll name it question E. What does question E say? What does question E say? What is the voltage when the current is 2 amps? Okay? So again, I come on the graph, I go where 2 amps is. Where is 2 amps? And then I locate the voltage. Where is 2 amps? Okay? 2 amps is here. This one, 2 amps. So I want to find the voltage. So I'll go on 2 amps, and then I come straight like this. I want to locate the voltage this side. What is my voltage at 2 amps? 3. Can you see? The voltage here, it's 3. At 2 amps, I go upwards. I locate the voltage. It's 3 volts. So it means on the voltage there, it is 3 volts. I'm just showing you how things are done. Okay? Okay? 3 volts. Okay? EF. They can say, on F, they can say, calculate the power in R1 if the current passing through it is 3 amps. Calculate the power if the current passing through it is 3 amps. The first thing is you write the formula for power. Okay? Power is equal to voltage times current. What is the voltage and the current at 3 amps? At 3 amps. That's what the question says. At 3 amps. Okay? Passing through it at 3 amps. So you go on the graph. You locate where 3 amps is. So you pick the current and the voltage. Where is it? Where is the graph? Here. Locate where 3 amps is. 3 amps is where? It's here. So you come 3 amps, you go upwards. Then you pick the voltage. What is the voltage at 3 amps? The voltage is 6. It can be 6.1, 6.2, 6.3. It doesn't matter, or what. So meaning the voltage there, it's what? 6. Okay? The voltage there is 6. So meaning that when I'm calculating, I'll use 6 or 6.1 or 6.2, whatever voltage it is. Okay? So to be 6, I don't know if it's 6.1 or 6, times current it's 3, as you can see. So it is 18 watts. I'll just open your mind, you see how questions for diagrams come. Whenever questions for diagrams come, the answers are drawn on that diagram. You just draw a straight line and then you take it this other side. Okay? Okay? So when diagrams come like this, when they're like this, you pick like this, you come like this, you go that direction, you pick the answer this side. Same thing, you come like that, you go this other direction, then you pick the voltage that side. You go like that, pick this side, you pick the voltage the other side. This side is always voltage. Okay? This other side is always current. Make sure you practice so that you have understanding. So these are what we call voltage current graphs. You always pick answers from those graphs. Okay? Okay. Anyway, the answer is this one. I was just drawing this to make you understand. It's not necessary this part. I'm just trying to make you understand. Okay, we've come to the end. Thank you for listening.